Ladies and gentlemen, alums, parents of a potential future alum, at least one I see here, and we'll have some more come in, I'm sure. But we have a great activity planned for today. We have faculty speaker. So this is the 8th annual lecture series in honor of Professor C.N.R. Rao. He has the Bharat Ratna designation. He's also the Linus Pauling Professor at his institute there in Bangalore. I'm Dan Hurleman, Professor of Mechanical Engineering and Executive Director for International Advancement for Purdue. It's great to be here in Delhi. I think it's our first time to do the lecture in Delhi. We've had 8, and we've hit a lot of cities in India. But this trip has been particularly interesting. We were in Delhi for the first part of it, and now for the lecture. Of all the nations in the world that Purdue partners with, and we have students from over 100, India is unique. Nationwide, we're the 2 largest democracy. You're the largest democracy. We're not as large, but we think are important as well. And there are a couple stats. You know, we believe we have the largest number of Indian undergraduate students of any university in the US, roughly 1,000. We have roughly 1,000 grad students on campus, and that's Purdue's largest number of graduate students from any other country. So India plays a special role for Purdue, and we're really thrilled to be in partnering with India in many ways. Professor Rao is a very interesting character. He's one of the folks that took full advantage of his time at Purdue. He got his PhD in 2 years and 9 months, but I remember we've talked to him, and he wrote papers with several other departments at Purdue, not chemistry, separate from his major. So when you say take advantage of all the opportunities at Purdue, like all the student organizations and the like, he did that in a very interesting way, writing journal papers with multiple departments while finishing his PhD in 2 years and 9 months. So very unique individual. We're thrilled to have alums like him, and we have so many others in India. You probably know he was the science advisor to the Prime Minister for 2 terms of multiple years. He now is with an institute he founded. He has been to these before. Today, unfortunately, he's unable to join us. The other thing I'd like to point out is we have, could you put up our sponsors? Oh, they're rotating. Okay, so let's wait to, no, we have corporate sponsors, alumni sponsors who've helped us do this lecture series. So we have platinum sponsors, Dr. Reddy's Laboratories, Managing Director G.V. Prasad is a Purdue alum, and our Sanjay Reddy, also the vice chairman, is our alum. TVS, Venu Srinivasan is our alum, TVS Motors. Black and Gold sponsors, we have SMT, Bhargav Katadia is with them, the Purdue-India Alumni Network, DCM Shriram Industries, so that's Rudy Shriram. He's our joint president of that institution, and Purdue for Life, the Purdue Foundation. That involves now the Purdue Alumni Association. So we much appreciate, there's the platinum sponsors just in time. We appreciate their support, which allows us to come with a delegation who you've seen. I'd like to now introduce Heidi Arola. She's our Director of Global Partnerships, but she also directs the Purdue-India collaboration. And she'll come up and introduce our speaker. So thank you, Heidi.
Good afternoon, everybody. So again, I'm Heidi Arola, Director of the Purdue-India Partnership. So I've had the honor of coming to India for 6 of the 8 lecture series, and last year's was online, which was also very exciting. So every year we choose a different theme to highlight for our series, and this year the theme is the future of food and agriculture. And we're honored to have here with us today the head of the Department of Agricultural Economics, distinguished Professor Jayson Lusk. So he's going to be delivering a 20-minute keynote, and then we'll move to a panel discussion with 2 other Purdue faculty, Professor Kingsley Ambrose and Associate Professor Dharmendra Saraswat. And they're both from the Department of Agricultural and Biological Engineering. So I'd like to start by reading Professor Jayson Lusk's brief bio. We're really delighted that he agreed to join us here today. He is a distinguished professor and head of the Agricultural Economics Department at Purdue University. He's a food and agricultural economist who studies what we eat and why we eat it. He's published more than 260 academic journal articles and 6 books on these topics. He's testified before the U.S. Congress on multiple occasions and is frequently cited in major media outlets such as the New York Times and the Wall Street Journal. He is a fellow and past president of the Agricultural and Applied Economics Association, which it blows my mind that he's only slightly older than I am, and he's done all of these amazing things, written 6 books, the president of a major professional organization. It does make one feel a little bit inadequate sometimes. But we're very, very pleased that he's here with us today. And if you want to learn more about him, he regularly blogs at www.jaysonlusk.com, and he can be followed on Twitter at Jayson Lusk. So without further ado, please welcome Professor Jayson Lusk.
Thank you, Heidi. It's such a pleasure to be with you all here today. I like to walk around when I talk, so I hope I don't trip over this table. So it's been such a pleasure. We've been in India about 1 week. This is my first trip to India, and it's been a really fantastic time. I've had lots of good food and great dinners, and so I get to maybe incorporate some of this discussion. Oh, you don't have to do that, Dharmendra. Wow, okay. We'll have to move it back. I appreciate you looking out for my well-being. Very kind of you. So while I do study food and agriculture, I'm not going to pretend to be an expert on Indian agriculture, and I think that's why we're going to have a great panel with a couple of my colleagues at Purdue who maybe know a little more about the context here in India. But I hope I do know a few things that can get us thinking about some of the big challenges facing food and agriculture. So I'm going to talk about the future, but I'm going to mainly wait to the end to talk about the future. I'm going to start by talking about the past and some of the big challenges and problems that have motivated thinking about food and agriculture. So probably the most famous problem, I think, that's been confronted in our food world is the problem of how are we going to have enough to eat. And that problem is probably most associated with this guy, Sir Thomas Malthus. He was writing in the late 1700s, and he introduced this concept here. The blue line that you see is essentially a production function. It shows what happens as you add more inputs, do you get more output? And generally, if you add more inputs, land, labor, water, you're going to produce more food. But he introduced this really important concept, a concept I like because I'm an economist. It's a concept called diminishing returns. And the idea is that as you continue to add more output, as you continue to add more input, you get more output, but at a diminishing rate. In his case, he was interested in labor. He lived in England, and they have a small island there, not a lot of land, and his concern is we're continuing to add more labor to this fixed amount of land, so the amount of output that can be produced by each worker at some point will start to fall. And so his concern when he looked out towards the future was we would have a growing world population, and the amount of food that each person in that population could produce would fall over time. And the words he used to describe that potential problem was misery and vice. You have a very large population living on the verge of starvation. So what do we do about this problem? There is no easy solution, and there have been many thoughts about this over the years. One potential solution is let's try to reduce population or slow population growth. Probably the most prominent example of that is China's one-child policy that they had in place for a number of years. For a variety of reasons, in democracies and in the Western countries like the United States, this kind of policy hasn't been very popular, in part because it's seen as paternalistic and sort of too controlling. So what are the other solutions? Well, maybe another solution, if you need more output, if we need more food, let's just add more resources. We can add more water, we can add more land, we can add more labor. Of course, with the labor, I already mentioned the problem. You have diminishing returns. So at some point, each additional unit of labor is only going to have a small effect. But land, there's only a fixed amount of land. We can't keep adding more to it. And even if we could, we'd be worried about it because it would create environmental problems. The same with water, too. Another possibility is to maybe change behavior, and I'll speak about that in a moment. Maybe consumers can choose different diets that have lower environmental footprints, or farmers can change and make different management practices that either produce more output or lessen the impacts on the environment. But the one I really want to focus on and advocate here for is innovation. Innovation, entrepreneurship, agricultural research. Why do I think that's such an effective solution? So these are the same graphs I showed you before. What innovation has done over time is it's enabled us to escape this Malthusian trap. That production function is still there, but we can figure out ways to jump up on a new production function. And if we can do that for any given level of input, any given level of labor, we can achieve more food production at the same time. So how do we do that? It's new crop varieties, it's application of fertilizer, and it's new knowledge, new management, tinkering around, experimentation. It's not just one thing, it's a whole host of things that allow us to jump up on these new production functions. So has Malthus's concerns come true? Has his, I wouldn't call it a prophecy, but has the concerns have been expressed come to bear? Well, certainly on the population side, he was right. We see this exponential growth in population that's occurred over the past few centuries, really, but even in the past couple hundred years, a dramatic increase in the world population. And it's because of that concern, what we see is, it wasn't just Malthus writing 300 years ago, but roughly every 100 years or so, somebody comes along and resurfaces a version of this concern. So if we fast forward like 100 years after Malthus, then we have Sir William Crookes. He was a president of the British Association for the Advancement of Science, writing in the late 1800s. And you can read his quote here. Essentially, he was re-expressing a version of the Malthusian concern. In his case, he was worried about the growing population in the United States. He was worried about my ancestors, that we were going to consume all the available wheat and not leave any for his fellow countrymen in Britain. And he was really worried about what that was going to be like. In his time, actually, this spurred a lot of concern and consternation. It was known as the wheat problem at the time. It was probably one of the causes of some of the research that ultimately led to the innovation and the discovery of synthetic fertilizers. We can get a little closer to more modern day, the late 1960s, and find people like Paul Ehrlich. He's a well-known Stanford biologist. He wrote a best-selling book at that time called The Population Bomb. And these are the opening sentences in that book. Essentially, he said this, worry about feeding the world population, it's already over. Millions of people are going to starve by the 1970s. Apparently, this sort of apocalyptic concern is one that was very popular because he appeared on the Johnny Carson show over 20 times. So if you don't know Johnny Carson, he was probably the most well-known late-night comedian of his era. So all these concerns keep coming back over and over again over the years. We knew that population increased, but what about starvation? We're all hungry, right? Well, actually, for most of the world, the answer is we're better fed than we've been in the past, at least in terms of the number of calories. So these are data, they're a little bit old now, at least a decade old, but still, if I updated it to the most recent data, the story would be even more dramatic. But what we can see is that despite the rising world population, the amount of calories available per person have actually risen not fallen as the Malthusian concern predicts. So across the world, almost a 30% increase, not in total calories, but in calories per person, which means that total calories are even, much higher than 30%. So people, are actually better fed today than they were in the past. You can see this coming out in a variety of ways. This is data not just on hunger, but on poverty, at least one measure of poverty. And if you go back to the early 1800s, over 90% of the world's population was living in poverty. Today it's something less than 10%. So 10% is too many, but at least it's far better than 90% today. So, how did this happen? Again, I think the answer was innovation, productivity, entrepreneurship. If you look at U.S. agriculture, and I'll show you a slide on Indian agriculture in just a moment, this is one example of that kind of productivity growth. So the top blue line shows total food output since the late 1940s. And total food production in the United States is up over 180%. At the same time, many of the key inputs to agriculture have fallen. So notably, labor. So we're using 76% less labor in agriculture in the United States than we did in the 1940s. Now that's the opposite of the Malthusian prediction. Not only are we getting more food, we're using less labor to produce that food. It's true of other inputs too. Land, for example, 28% less land in production in the United States today. Even key inputs like energy have fallen in recent years compared to the 1940s. And really, when you think about what productivity is, it's just the ratio of these two things. Total output divided by the sum of all the inputs. And if that ratio is growing over time, productivity is growing over time. So if I looked at a study by our U.S. Department of Agriculture on Indian agriculture, we can see that Indian agriculture has also become much more productive over time. So this is calculating productivity. Again, productivity being the ratio of outputs to inputs compared to the 1980s. So you can see, at least as of 2008, in Indian agriculture, the dark dashed line is the average for the whole country, is 2.2. It means for every unit of input that gets applied today in Indian agriculture, you get 2.2 times more output today than you did in 1980. And that's how we've been able to escape this Malthusian problem. But again, it's a problem that never goes away. It's one we always have to think a bit about. These are world food prices. The black line is showing you inflation-adjusted global food prices. This is an index that's calculated by the UN Food and Agricultural Organization. And during the 70s and 80s and 90s, we saw a pretty steady fall in global food prices. But we've seen a spike in 2010, 2011. It kind of fell back down. And then here recently, in the last 2 years, another big spike in food prices. When you see food prices increasing, that's a signal. Prices signal scarcity. So it's telling us that food is relatively more scarce now than it was in the past. So why has that happened in the last couple of years? Well, we've had a global pandemic that disrupted trade and added costs to the system. Of course, even more recently, we have issues like the thing that's going on, the crisis that's in Ukraine and Russia. Ukraine is a major exporter of crops like wheat. Russia is a major exporter of fertilizer. These things are having a big impact on global food markets. So the Malthus hasn't totally gone away, but the problems are not just about food prices. They've expanded and diversified over the years, maybe in part because as we have become better fed and become wealthier, our concerns have broadened and become more diversified too. So these are just a few headlines from around the world. And I think one common theme, there's even a headline from one of the Indian papers from a couple of years ago that you see is not, whoo, thank goodness, we got all these people fed. We've been worried about this for 300 years. Actually, one of the major concerns now is we have a broken food system. And that's probably one of the most predominant things that you see mentioned in popular writings about food and agriculture. And why is that? It's a whole list of issues related to health outcomes. So it's not just calories, but are we getting enough nutrients? Of course, it's about environmental outcomes, the impacts of agriculture on climate change, worries about animal welfare, food safety, about the structure of the food system. Are the benefits and returns equally distributed amongst farmers and consumers? So, the concerns have sort of shifted and made many people concerned about our food system. Unfortunately, there haven't been very easy solutions to these problems. Here are just a few headlines of the ways different countries have thought about trying to solve them. So Mexico, for example, has a soda tax. But they're often solutions that people don't like. So Denmark, for example, passed a saturated fat tax several years ago that was repealed about 2 years after it was implemented because the public revolted against it. We have an example here that's probably a little closer to home. Sri Lanka last year decided to essentially move in a mandated way towards organic agriculture. They prohibited the use of synthetic fertilizers and certain pesticides, and as a result there you saw skyrocketing food prices and dramatically falling farm profits. Of course, there's a lot going on in that country other than this at the same time, but you do see sometimes taxes and bans and mandates often haven't achieved some of the outcomes that people have really hoped for. Why do these policies often fail to live up to their hopes and aspirations? There are a variety of reasons. I'm going to give you kind of two, but one thing that's a real tricky problem, I think, is that food policies are often regressive. And what I mean by that is the impacts are, the costs are often disproportionately borne by lower income households. One way to think about that is this famous economic relationship called an Ingle curve. It's named after the British scientist who discovered it. Each dot is a country, and it just plots total income of a country or per capita income against the share of income that gets spent on food in a country. So on the far right-hand side, you have the United States, relatively wealthy country. We spend less than 10% of our income on food. On the left-hand side, you have lower income countries that tend to spend a higher share of their income on food. This same relationship holds even if you just focus within a country. So if we just picked India or we just picked the United States, what we would see is that within the country, higher income households spend a smaller share of their income on food. So the challenge is if you enact a policy that increases the price of food, who feels it? It gets primarily felt by the lower income households because food is consuming a larger share of their budget. Another challenge I think we often have is, we all want good food. We want food to taste good. We want it to be healthy. We want it to be convenient. We want it to be affordable. We want to have our cake and eat it too. So when you ask people what they want out of the food system, we often say we want things, either to our politicians or on surveys. But then when we go to the grocery store and spend our money, we make a different set of choices. I want the cage-free organic eggs, but when I go to the grocery store, they're 3 times the cost, and so I choose the cheaper conventional alternative. And so I think that's a real challenge, particularly when we think about the gap between behavior in grocery stores and policy making on the one hand. So maybe to just give you one example of that, I'll show you some results from a survey that I conduct every month of over 1,000 US food consumers. And this is just one question that we ask on the survey. We ask them, when you go to buy food, what's most important to you? You have 100 points. Now allocate this 100 points to these 6 issues in terms of how important they are to you. Now, obviously, people care more than just about these 6, but this just gives you a little sense. And what we see is, generally across most consumers, the 3 most important things are taste, nutrition, and then affordability. And the things that we really, often the reasons that people say our food system are broken, people tend to rank a little bit lower, whether it's social responsibility, environment, and these sorts of things. We can also see here, I have the results split out by income, and we can see something like the Ingle curve happening here too, that affordability, the amount of points assigned to affordability is much higher among, there it is, it's 24 there, much higher among the lower income consumers. So again, when we think about policies that change the price, it's going to be felt most acutely by lower income households. And I think this does illustrate the challenge of food policies is if you make a change, then food is not as tasty, or it's perceived as not being as nutritional, or it increases the cost, that will tend to trump all the other issues and benefits that may come about. So I'm not going to go into a huge detail there. So what I want to do is give you some examples maybe of if some of these policies aren't as effective as they could be, what are some things to think about on the innovation side? So let me sort of restate the Malthusian problem for you. So there are 7 billion people on the earth today, roughly speaking. The predictions are that by 2050, we're going to have 10.9 billion people. So what are the extra 3.9 billion people going to eat? Not only is that a problem, but how do we feed that extra 3.9 people in a way we can feel good about? Where we're not ruining the environment, where we're leaving a better world to our children and grandchildren, making sure the food that we have is tasty, and also understanding the fact that even today, not everyone is well fed. So let me go back to this curve that I showed you before and put it in context. So I mentioned this production function. We add more inputs, more water, more fertilizer, energy, land. We get more output at a diminishing rate. We try to innovate so we can jump up on a new production curve. And I think the way that this is often talked about is the way I did at the beginning, which is we have a growing world population. How are we going to feed them? And the answer is normally you say, okay, well, for a given amount of inputs, if we can innovate and get on a new production function, we can produce more food. I think this is an argument that many people in our more modern world have a hard time with, in part because we produce a lot of food today. In fact, if you just, in a purely accounting sense, look at the number of calories we produce enough calories to feed every person on the planet. So in some ways, it's not really a production problem, it's a distribution problem at the moment. Now, that doesn't solve the extra 3.9 billion people that are going to show up. And I think one conclusion some people take from that is to say, therefore, we don't need all this innovation. It's too much, right? That's often the conclusion that many people reach. I think it's the wrong conclusion. And one way we can see that is just to take this exact same relationship but redraw the arrows and to say, let's assume we don't want any more food. We want the same amount of food, so I'm going to hold the amount of food production constant and say, if we can innovate, if we can jump up onto a new production function, we can use fewer resources. Less water, fewer pesticides, fewer chemicals. And that, to me, is a story about sustainability. That if you want sustainability, you also want innovation too. Because innovation allows us to enjoy the food that we have right now, but enjoy that food while using fewer of our world's resources. So I'm going to end by just giving you several examples of what does innovation mean. I've been talking about it at a really high level, so let's bring it down to the practical level and talk about some of the actual innovations. And I'm going to do it by starting off by sharing some of the things that my Purdue colleagues are up to, because one of the great things about working at a great university like Purdue with a great agricultural college is I could get to see all the things that my peers are up to every day, and it makes it a fun day to go to work. So at Purdue, this picture I have in the upper left-hand corner, this is something called a controlled atmospheric, I'm forgetting the rest of the name, growth chamber, but essentially what this allows you to do is to simulate an environment or climate. We could put plants in there and expose them to the same temperature that you felt in Delhi for the last 2 weeks. And like you, the plants would also be stressed. And then we can put those same plants, they go on a conveyor belt around the corner, and there are all kinds of imaging equipment there. We can do infrared technology, X-rays. We can even look through the pots and look at the plant's roots. And the idea is that we can start to understand and predict when plants are going to have problems, experience stresses, even before we can see it with our own naked eye. Not only that, we can then start to associate these changes with genetics and marry the phenotype, what we can see in the plant, with the genotype, the genetics, so that we can start crossbreeding, creating new plant varieties that are less stressed in certain kinds of environments. We're doing this kind of work not only in the lab, but also in the field. So the other images I have in front of you there are fields and using remote sensing technology and digital ag, big data. So this could be either from a satellite or from a drone. And the idea here is that not only can we manage an entire field, several hundred or thousand acres, but also we can begin to manage a field on a much smaller scale, let's say a meter by meter basis. What we can see in most fields, even in a place like Indiana, which has a very fertile cropland, and just if you're driving on the highway, it all looks the same. But what you can see is if you look at any given field, there's an incredible amount of variability. And what we can do is start to see maybe some of that field maybe needs fertilizer and some doesn't. So rather than just blanket applying fertilizer across the entire field, let's be more judicious about it and only apply that fertilizer where it's needed. That allows the farmer to save money, but also has an environmental benefit because if we don't over-apply fertilizer, it won't run off into the waterways. We're also using some of these technologies, I think Professor Saraswat may talk some about this, as early detection for insects. So I grew up working on farms, and if you wanted to determine if a field might have been invaded by some insect, you walked out in the field, you walked down the rows, and you would look under the plant leaves and see if there were eggs or bugs on the leaf. Now with some of this technology, we can start to see it, some of the damaging impacts on a field before even somebody can with their own eye. Why does this matter? How does it help? Again, the idea is if you catch it early, you can apply fewer insecticides. You can apply them more judiciously. Maybe you don't even need to cover the whole field. Again, saves the farmer money, but also has some environmental benefits. Another fun competition at Purdue is a student competition, a robotics competition. It's held every spring at Purdue University. Student teams from around the country come to Purdue to participate. And what they do is they have to create a self-driving machine or tractor that can kill weeds. In this case, this is the Purdue University's team, and what this machine does is it drives itself in the field down the row, and the machines are looking at each plant and using machine learning and these sorts of techniques, try to distinguish, is this a corn plant or is this a weed? And once it decides this is a weed, I'm just going to put one squirt of herbicide on that plant rather than spraying the entire field. This is a student competition, so of course the students have all kinds of creative ideas about how to control weeds. I think one team had a machine that shot a laser at the plants. That sounds a little scary to me, but another team had maybe a mechanical arm that would pull the weeds as well. So again, what will these teams come up with next? I'm not sure, but I'm really excited to see what kinds of things they'll study. The first couple of examples I gave you are those that are kind of high tech, used in big, kind of large-scale agriculture. But of course, we care about agriculture across the world. And one example of an innovation there is something called the PICS bag. That's the Purdue Improved Crop Storage bag. It looks like a simple bag, but what this bag does is it enables a farmer to harvest their crop. If it's put in a bag, it protects that crop from the weather and from insects. This solves a really important problem for farmers. One challenge with farming is that it's seasonal. And when it comes time to harvest your crop as a farmer, the same is true of all of your neighbors. So all the harvest comes available at the same time. What happens when you have a lot of supply of corn or wheat or rice all at the same time? Prices fall, right? So at exactly the same time as a farmer you harvest and want to sell is exactly the same time prices are at their lowest. So one thing these bags enable farmers to do is to store that grain, hold on to it throughout the season until prices can improve. Not only does it have an economic benefit for the farmer, of course it helps produce food waste and food losses because all that grain required resources to be produced, so we don't want to lose it, and these sorts of bags can be used to help do that. We're proud at Purdue to have 3 World Food Prize laureates. This is sort of the agricultural equivalent of the Nobel Prize. The guy in the middle I'm going to pick out because he graduated from my department in agricultural economics, Akin Adesina. He's currently the president of the African Development Bank. He was previously the minister of Nigeria, and he won a World Food Prize because he and his teams developed a method using mobile phones to order and buy fertilizer. And this allowed the farmers to get around some of the big monopolists that exist that control the sale of fertilizer. So it enabled much wider spread and more affordable use of fertilizer in that country. we think about technology and innovation. It's not just about prices. It's about all kinds of other things. And in this particular example is about animal welfare. And I think one reason I bring this up is I think a natural inclination many of us have is if we want to improve animal welfare, natural is better. In this case, I'm talking about egg-laying chickens. And the thought is just open up the doors, let the chickens run free, right? Isn't that the best for the chicken? That sounds good until you realize there are really hot days outside. The chicken doesn't want to be outside any more than you or I do. Also, there are birds of prey, hawks and eagles. There are dogs, other things that can eat the chickens. Also, what are they eating? Do they have a good diet or not? So there are reasons that farmers, have to bring animals indoors in comfortable environments to feed them more nutritious diets and protect them from predators. But one concern is maybe they've gone too far. So at least in the United States, a lot of egg-producing chickens live in very small cages. And so how can we do better? And I think even here, science and innovation can help us think about housing technologies that help provide the birds with more amenities that enable them to exhibit some natural behaviors, while at the same time being affordable for food consumers. So one example of that is called an enriched colony cage system. So it gives the birds more room, has perches the birds can jump up on, allows that little barrier you see there allows the birds to go behind a little enclosure when they lay their eggs. So I guess the chickens get a little embarrassed sometimes, maybe if they don't have some privacy. So the idea is that through science we can learn which of these amenities are most important to the animals and how can we do this. If you really want the Ritz-Carlton or the Oberon of chicken living, it's the Roundel system. So this is created by some Dutch scientists at Wageningen University that really, I think went full on. Now, eggs in that system are going to be much more affordable, but it's a system very much based on some of the science of animal welfare. I talked about calories, but at the same time, it's not just calories, it's the quality of food that we have too. And here we see that innovation science is also focused on that nutritional aspect. One of my former students, Abdul Niako, he works in Mozambique on orange flesh sweet potatoes. The most common variety of sweet potato in that country is a white flesh sweet potato. Unfortunately, it's lacking in many of the nutrients that people need, and it's a staple crop, so it's the most commonly consumed crop in that country. And so they're breeding new potato varieties that are orange flesh that have many more micronutrients that if the public would consume could provide some substantial nutritional benefits. The challenge, of course, is that people they like the taste of their old varieties. They like the texture and the way it feels when they cook it. And so his team is working on breeding new crop varieties that have both the same nutritional benefits while also providing many of the same taste characteristics as well. Another example is golden rice. I don't want to spend a whole lecture here talking about GMOs, and I know that's a controversy that's very controversial with some, but the one thing I do want to leave you with is that GMOs are not just about Monsanto and the big, chemical companies. There are also independent scientists using these technologies, even through nonprofit companies, to try to create new crop varieties that can improve the welfare of humans. In this case, golden rice is a variety of rice in which a daffodil gene, it's a flower gene, has been introduced so that the rice conveys beta-carotene, which the body can convert to vitamin A. And the thought is this is a micronutrient that can help reduce night blindness in many parts of the world where vitamin A is scarce. Speaking of the GMOs, and now we're maybe getting those things that might make you feel a little strange, there's a competition that's held every year in the United States at MIT. It's called iGEM, Internationally Genetically Engineered Machine Competition. Most of these students' teams are genetically engineering bacteria or yeast to do all kinds of interesting things. This particular group of students are from California, and they genetically engineered a yeast to do something really interesting in food, but it's not in the food. So the problem they were addressing was related to olive oil. There were producers in California that were wanting to plant olive trees, and come to find out that most of the olive oil that's consumed inside the United States is imported from Spain or from Greece or from Italy. And apparently, by the time that olive oil reaches the United States, it's gone stale or rancid. In fact, they did a taste test with many of the consumers in a farmer's market there in California, had them taste stale, rancid olive oil and fresh olive oil, and asked the consumers, which one do you prefer? What do you think consumers mainly preferred? Well, most consumers said they preferred the stale, rancid oil because it's all they'd ever had. They didn't even know what the good stuff was supposed to taste like. And that's how accustomed that consumers have been. So this team, what they did is they genetically engineered a bacteria that could detect, that would produce a signal when it came into contact with those rancid flavors. And that signal could then be picked up with a digital reader, and they could, with a very easy and affordable test, identify whether olive oil was fresh or not, so that hopefully we Americans can start enjoying the good stuff as we should. So last slide here, there's all kinds of really, I think, interesting innovations, not just at the farm, but in the food side too. People are working on 3D food printers. We're working on growing meat without the animal, the lab-grown or cultured meat. And we're even making innovations in the kitchen. I talked to a CEO of a company in Britain who is thinking about how to make your lives more convenient. What he did is he attached sensors to the arms of celebrity chefs as they were preparing a meal, and he was recording all those movements in the computer, and then he can then program these robotic arms to exactly replicate the movements of these chefs. So you can imagine you come home from a hard day's work, you just want to kick up your feet up and relax, but now you can just go in your kitchen with a touch of a button. You can have Martha Stewart's own hand movements, making you dinner in your own house. So, not all these technologies are going to be profitable. Some will undoubtedly fail, but I think the idea is that many of our world's pressing problems, I think, could be most effectively addressed by unleashing the innovative power of our students, by funding and investing in agricultural research. And it's exciting for me to have spent the last week getting to travel across India, getting to meet with professors and students that are working in this space. And despite the fact that we do have a lot of problems facing us in food and agriculture, I'm personally very optimistic about the future. So I'm going to stop there and I think turn it back over to Heidi, right? Okay. And I'll move this back now that I haven't tripped.
Thank you so much, Professor Lusk. At this time, I'd like to call our other panelists to the stage. So we have Dr. Kingsley Ambrose and Dr. Dharmendra Saraswat. You could take a seat here, and the staff will just get you mic'd up. So Dr. Kingsley Ambrose is a professor of agricultural and biological engineering at Purdue University. Dr. Ambrose earned his BE and ME degrees in agricultural engineering from Tamil Nadu Agricultural University in Coimbatore, India, where he's currently a Fulbright scholar. His research interests are in particle and powder characterization, particle modeling, particle design, and safety during powder handling, such as reducing grain damage during harvest and handling, preventing dust explosions, and improving the performance of granular fertilizers. He has co-authored or authored 90 peer-reviewed journal articles and 5 book chapters. Dr. Dharmendra Saraswat is an associate professor in the Agricultural and Biological Engineering Department at Purdue University. He maintains a solution-oriented approach to research to provide scholarly and valuable contributions to developing decision support tools for watersheds, row crops, and indoor plants. The tools integrate geographic information systems, GIS, remote sensing, open source software, Internet of Things devices, and artificial intelligence for providing solutions. And I'm going to act as your moderator today, and I'll kick off the first question to our guests, or not our guests, but our panelists. So Professor Saraswat, Professor Ambrose, you've just listened to Professor Lusk. You've heard his keynote in which he's asserted his vision for the future of food and agriculture. And the main theme that we heard in his talk is innovation. Innovation will define, and needs to define the future of food and agriculture. So I would like to hear from each of you, and I think we'll start with Professor Saraswat. What are 2 or 3 defining features of the future of food and agriculture in your view? And you can please go ahead and just introduce yourself when you respond to that question.
Sure. Thank you very much, Heidi, and thank you, Professor Lusk, for a very enlightening talk about the future of food. And I will straight away jump to my comments on the 3 important themes that you touched on: the labor, the land, and energy. Because having about 10 years of experience working in India as part of the National Agriculture Research System, first as an assistant professor, and then secondly as a scientist in Indian Council of Agriculture Research before going to US, I feel that all these 3 are very, very important for India. And if I take the liberty of extending it to globally, these 3 resources are very, very important all over the world. We need to manage our land in a very, very careful manner so that we leave the land in a good state so that future generations can use it. And for that, there are a number of ways that technology allows us to manage them. As Professor Lusk alluded, that we have technologies that allow us to manage plant by plant. Same way, there are technologies available that allow us to sense the field, to assess the variability, whether the variability comes from the nutrient variability or the variability comes from the structural variability in the soil or the variability that exists due to the moisture availability. So there are a number of radar technology that is available. They are both satellite based, they are also drone based, and I'm pretty sure that drone based technologies are very important for India. Indian government is taking a lot of interest in promoting those technologies. So those technologies already exist that allow us to manage our land in a very, very judicious manner. Similarly, when it comes to labor issues are really very important for Indian agriculture as well. And it is because of the fact that agriculture requires labor at very, very critical times. So that when you are planting the crop, you need laborers. When you need to take the weeds out, you need laborers. When you have to apply chemicals to take control of weeds, you need laborers. And when you are harvesting, you need laborers. And for all these events, you need an assured labor availability. And what I am being told by my colleagues is that one of the reasons why mechanization is accelerating in India is just because of the fact that labor is not available at the most critical times. So we need innovation, we need innovative technologies so that the dependence on labor can be minimized. And here again, I would like to introduce the concept of drones that serves as our eyes in the sky so that we can learn as to how our crop is behaving, whether it is stressed or not stressed, whether it needs some kind of a nutrient or does not need, because there are some kind of a spectral signatures that sensors attached to the drone can find out and inform us to make those kind of decisions. And thirdly, water. India, despite having a wide amount of rainfall, has several pockets where the rainfall is not uniformly distributed, where we do not have enough water for drinking purposes. So that's why we need innovative technologies so that wastewater can be put to use for meeting not only the agricultural need, but also providing water to other sectors of the economy. So these 3 themes that Professor Lusk touched in his talk definitely need innovations, and we are all part of developing those. And I'm also working with my counterparts in Indian Council of Agriculture Research and the State Agricultural University so that those new ideas can also be shared with them. And I also learned from the ideas that they are experimenting related to these 3 teams in India so that I can take them back to US and apply and test out in those conditions too. Thank you.
Thank you so much, Professor Saraswat. So we heard land, labor, and water, and your points on each of those 3. Now, Professor Ambrose.
Hello, good evening all, good afternoon all, and I'm Kingsley Ambrose. So again, Dr. Professor Lusk, gave a great talk on, the future of food and agriculture. He almost covered all the points that we were about to talk. So a couple of things other than, phenotyping, sensing, those are very important, like future, that helps with the productivity and production aspects. That will definitely help. And then the genetically improved or the breeding, improved by breeding aspects like the, golden rice, orange corn, or, sweet potatoes, etc. Those will also be, definitely useful. A couple of other things that I wanted to touch upon is one is use of like data, right? So we, at least, I work on the grain side of thing after harvest. So as far as I know, grain handling and post-harvest management aspects, US is very far ahead and well developed. When we compare with other wealthier countries too. But still, we do not utilize much of data. Like we produce a lot. We have actual energy content that we are producing, like proteins, starch, etc. But we don't we fail to monitor how we are using those food and energy aspects when it goes to the consumer. So use of data will be I think will be a next big thing, at least in grain handling and post-harvest management. When I think about the developing countries, one of the point that I usually mention is the scaling of technologies. Like we develop for example in India too, we do lots of research, we do develop lots of technologies, but we had great discussion on the land holding sizes. Land holding is not very uniform across different population or different states, etc. But the technologies that we develop is kind of common for all the land holdings. So how do we scale different technologies to different people or different consumers? That also will definitely help with the future productivity and production aspects.
Thank you so much. Very good point. Now, Professor Lusk, in your talk, you talked a lot about government policies and how they've shaped trends in food and agricultural production and consumption. And you mentioned, many of the failings and some of the unintended consequences of some of these policies. So, I guess pushing that a bit further, do government policies matter? And what impact have they had in the past? And how do you think government should be involved in the sector in the future?
I mean, I do think they matter, can have big impacts. In fact, the 3 of us probably wouldn't be sitting here if it wasn't for government policies investing in food and agriculture. In fact, Purdue University exists because of the Land Grant Act in the late 1800s that where the government made an investment in agricultural education and research. And so part of my salary, and I'm quite sure part of their salaries comes from the US federal government to study agricultural research and then to turn around and try to extend that knowledge to farmers in Indiana and the rest of the world. So I think that's an example of a policy that has been extraordinarily effective across the country and across the world. There are many others I could give that probably haven't been as effective, but I think that one, and the infrastructure we have both to fund research and to communicate that research is an example, I think, of one that's been extraordinarily successful and has had, I guess, a lot of foresight when it came into existence. So I saw it was a trivia question when I came in here earlier today that who signed the Land Grant Act into law? Yeah. It was Abraham Lincoln. So.
1869?
Somewhere in there.
Yeah. 67, I think it might have been. But yeah. Okay, great. Thank you. Would anyone else like to comment on that? Otherwise, I'll move on to my next question.
Yeah, in fact, I completely agree that even in India, government of India invest a lot in the state agriculture universities and Indian Council of Agriculture Research and a number of other initiatives that are taking place, such as Startup India, where a number of startups are being encouraged. And just yesterday, I was listening to the Prime Minister's comment that he was making in some meeting that every week India is producing one unicorn, and one unicorn means a startup that is valued at $1 billion or more. So every week India is producing a unicorn. So this has not been possible without government investing in that. So definitely government carries a lot of weight when it comes to developing policies that can spur growth in different sectors of society.
Great.
Just quickly, as long as, like in the United States, as long as NIFA is funding our projects, we will be okay. So, like same in, Indian conditions too, like, as long as, I think they have a plan of, finding a national research foundation or something like that.
Right.
So that would also be, definitely useful, to bring to the next level. So.
Great. Well, Professor Saraswat's point was actually maybe a good segue into my next question. When we think of unicorns, we think of a small startup that has just exploded and is, at the higher $1 billion level.
$1 billion, yes.
So let's talk a little bit about scaling. Now, I'll start with Professor Lusk. As our population grows exponentially, does innovation need to follow suit? So if so, how do we scale innovations? And are there any recipes for knowing when a technology is actually scalable?
It's a great question. Let me first mention a limitation to scaling in agriculture, which is agriculture is local, and how crops perform depends on the local water and temperature conditions. And I think one challenge that's been faced is sometimes even in developing countries, you have people enter a local region without knowledge of the local context and say, you just got to do things the way we did. And I think we've seen lots of examples where that doesn't work very well. So that's a challenge, but how can we increase the odds that technology can scale? I can think of a couple of things. One is to make sure people have access to the capital they need to have access to that technology. Technology is not always free. And so whether it's through farmers getting together through co-ops to, maybe you can't afford a tractor or a new harvester or something along those lines, but if you got together with 5, 10, 15 of your neighbors and you have some mechanism for sharing, that's a possible mechanism, as are others. I think, there are other mechanisms, I think, as well, but I do agree that this scaling issue is certainly one that's really key.
Yeah, and in fact, I would like to second what Dr. Lusk has indicated. Being part of the Indian Council of Agriculture Research a few years ago, and still being in touch with my colleagues, I know that Government of India and Ministry of Agriculture in particular has been promoting a number of custom hiring centers throughout the country. And what those custom hiring centers do is that they have all the machinery that local farmers may need in a region, and those machineries are provided to them through apps. So what they call is Uberization of agricultural machinery that is happening in the country in big way. And because my last posting with Indian Council of Agriculture was in the state of Madhya Pradesh, and Madhya Pradesh has a Directorate of Agricultural Engineering where they are promoting this in a really, really big way, and it is a very successful model. And as a result of that, the Indian Society of Agricultural Engineers, which is the largest professional body of agricultural engineers in the country, is very actively lobbying other state governments to follow that type of a model because it is time tested, it is successful, and it is used by farmers those who cannot afford to have those machines and have a large capital investment on those machines. So this is the kind of a model that Professor Lusk indicated, and India is very, very actively and in a very, very useful manner applying it with resource-poor farmers.
Very good. Professor Ambrose?
I would also agree, like scaling and, the custom hiring approach. If I remember correct, one of our Mandela alumni in Nigeria, he's doing that for tractors
Hello
and
Tractor.
harvesters.
Hello Tractor is the name of the app.
Yeah, I
that has been
forgot the
developed.
name. So they're doing in Nigeria like custom hiring of tractors and like same like
Right.
Uber, right?
Yeah.
So that hopefully down the line in India too, it will become the future of hiring. I've heard example in southern part of India, they do custom hiring for dryers, like large, high, huge capacity paddy dryers. They
Okay.
have kind of in common facility and people come and dry and go. So that could be one, future prospect.
Right.
If I could add maybe one more thing, and that is that if you're a near subsistence farmer, it's really risky to try something new.
Yeah.
And so one challenge with scaling is how do you try something new? How do you reduce the barriers there? And I think this is where ag research and extension is very helpful. If you have a third party that can show demonstrations in a local area, so that knowledge, like helping people learn whether this technology is going to work for your context, I think is really critical to scaling, particularly in contexts where if it doesn't work, you're not going to eat. And so, yeah, if I download a new app and my Uber doesn't come, I'm really disappointed, but I'm not going to die.
Yeah.
I may feel like it, for 5 minutes, and then I'll get on with my life. But in agriculture, these decisions, you make a decision to plant this, it's a really serious one. And so I think ways you can lower the barriers to learning about whether that technology works is really important.
Yes, that makes complete sense. Well, I'm going to ask one more question. I have several, but I'm going to limit myself to one more. And then I'm going to ask the audience for questions, so be thinking about yours. So I don't know if India, the program, the Jetsons, ever came here. But basically, a program envisioning, what life would be like. I think at the time it was probably in 2000, because it's a very old show. And in that show, robots are cooking for us, robots are cleaning our houses, and if I'm not mistaken, well, anyway, I'll lead into the question, which is, looking into your crystal ball, will there ever come a day when basically our regular meals are optional? So, you'll wake up in the morning and you'll have your bottle of pills, and there'll be a green pill and a red pill and a yellow pill, and those will meet all of your nutritional needs, and you really don't have to eat. So, what do you think?
My vision of the future is on Monday and Wednesday and Friday I'll have the pills, but there's still something really fundamental about cooking and sitting down with people for a meal.
Yeah.
So the other show that was very futuristic was Star Trek, and there was a Star Trek replicator. You just go, you push a button, boom, your food's there, and you sit down and eat. And I think a lot of times we want that convenience. If I've got a busy week and I don't have time, having that kind of convenience. And there are some products on the market, actually, you can Google it. There's something called Soylent out there. It's supposedly a drink, has all your nutritional needs, you don't have to eat. And there's some people that really value that kind of lifestyle, but it's really hard for me to imagine a world in which we want to give up that sitting down with family, enjoying a meal around the table. For me, I really like to cook, not every day, but on the weekends, let's say Saturday, spend 2 or 3 hours. And so I don't think we'll ever want to give up that sort of fundamental human characteristic.
Although maybe in like a disaster scenario, that could still come in handy, because then you have those pills for people in refugee camps or whatever, as some mechanism. So it sounds like there will be a day.
Yeah, and I'm thinking of how we train our astronauts who spend time in International Space Station. We train them to derive same satisfaction from dried food products or food products that are not available to them in the same form as we consume on Earth. So they have to go through a training process just to start liking those. So probably that day may be there where we will be consuming pills, but then it might take a generation or so before we forget that how to enjoy regular food and be satisfied just by taking those pills. So it is not going to happen in my lifetime. I'm very confident. And if it does happen, yes, I will follow Professor Lusk's route that Monday, Wednesday, Friday, pills are good, but I do want my regular food on other days.
My take is that I'll obviously take the pills as long as McDonald's sells it. Okay, so
McDonald's sells it.
but the thing is, yes, the future will be, probably moving towards that. Almost we are shrinking our food too. Like, many of us depend on energy bars, right? So kind of you know, towards slowly moving towards that future, like, you know, there are lots of, I know lots of food scientists working on those kind of, you know,
Yeah.
I forgot the exact name, but the nutritional tablets or something that's packed with, same thing like the soy, you know, example. It's packed with nutrients and energy. Hopefully there will be some.
Or maybe broccoli that tastes like French fries,
Yeah,
or
that's-
Yeah, there we go.
something like that.
Now
So
we're
you still get the taste satisfaction, but the nutritional value. So wonderful. We do have time for questions. So if our AV staff could perhaps help us with the microphone here. Somebody. We have a question over here. If you
yes.
could just wait a second until you get the microphone. Thank you.
So great talk, Professor Lusk, and a very interesting discussion. I had two quick questions. One was, so we experienced 2 years of the pandemic. So Bill Gates talked about how do we prepare for the next pandemic, right? I had a analogous question. Are there agencies which track plant pathogens? Like what if a disastrous pathogen would lay waste to a lot of the world's crops? Are there agencies which track that? And the second question was perhaps more directed to Professor Saraswat and Ambrose. In India, agriculture is also is a major source of employment. So where do you see mechanization, which we see in the Western economies? Fewer and fewer people grow the country's food. So how does India balance modernization and mechanization, along with the fact that a lot of our population also treats agriculture as an source of employment? Yeah, thank you.
Why don't you go first?
Okay, so that's a very, very appropriate question about keeping people gainfully employed in agriculture, and that is why, India has adopted a model that is different from the developed world, and that is providing more focus on rural development. So although 55% or so percentage of rural population is employed by agriculture, but very similar to Mahatma Gandhi's vision that we have to empower our villages if we want agriculture to be successful. And when I was a scientist at Central Institute of Agriculture Engineering in Bhopal, our effort was that the people that will be displaced by mechanization, they should still be part of the agriculture ecosystem in the form of becoming, say, mechanics who will be taking care of the implements and machinery that is going to be introduced. There could be some of those who could be part of providing those rural tools in the rural areas where it is needed. Same way, although drones are being envisioned to be our eyes to track all these diseases and other needs that are going to happen in agriculture, but during my days as agricultural scientists, we used to be thinking about using the same agriculture-related people in rural areas to be part of the solution, training them to learn how to process so that all the food and vegetable-related waste that are happening in rural areas nowadays can be minimized, and things of this nature, so that agriculture can also become quite remunerative. And what I gather is that the thought process is not very different now. Even the kind of efforts that are happening related to rural development are still on the same track, so that people can be gainfully employed in those areas rather than they start migrating to other parts of the country.
Thank you. Did you want
So,
to?
go ahead.
But just quickly to add that, one of my thinking of mechanization is like reducing drudgery. Like, there are lots of labor, they work hard, but we don't have any small equipments or stuff that ease their work, Those kind of innovations are still needed, That's again my thinking that would help again, increasing productivity and also increasing their performance. We may not displace labor, but help them to
Be more productive.
to be more productive.
Yeah, and I think that's just on that issue, the story of the United States, go back 100 years ago, 80, 90% of the population was in agriculture. Today, 2% of the population are farmers. And so what happened to all that labor? They found jobs in the city. So you need sort of other policy beyond agriculture to have employment opportunities for that labor. In fact, the average income of farmers today is well above the average in the United States, is well above the income of the average U.S. citizen. And so it has to be a conversation beyond agriculture to provide employment opportunities for other people. So you asked two questions. The other one you asked sort of me, one was about, is anybody tracking plant pathogens? The answer is yes, at least in the United States. The U.S. Department of Agriculture, they have an agency called APHIS, Animal Health Plant Inspection Service.
Yes.
I don't know if I said that right. I'm sure India has a similar organization,
Yes.
and there are international organizations that work in these spaces. And I think, I mentioned, crop breeding and about trying to, breed new crops that can have higher yields or more nutrients. Frankly, a lot of crop breeding is just trying to keep up with Mother Nature. So a new disease comes up, in soybean rust or something like that. It gets, just in weather patterns shows up. And so crop breeders are just fighting every year just to make sure yields don't fall.
Yeah.
So it's actually amazing that yields are actually increasing all the time. So this is a huge challenge in both plant and animal agriculture. You asked me about the pandemic and sort of resiliency. I think there's a lot of discussions going on there. I kind of have two competing thoughts. One conclusion I think that some countries have taken is we need to be self-sufficient. We don't need to be relying on imports from these other countries. My controversial viewpoint on that is self-sufficiency is a road to poverty. And what you want to think about is diversity. You want a diversity of places where you're buying from. One way to think about it is that by trading with other countries, you are diversifying your set of inputs. Imagine, in your local region, you have a drought. It's great that then you get to buy crops from other countries or other areas around you because you're not as subject to the whims of what's happening in your case. So in my view, the problem isn't trade, it's making sure you have a diversity of trade. And I think the same way maybe in thinking about our food production and processing and making sure that there's some distribution there so that if any one node in the network goes down, we have some redundancy in the system. It's expensive. Redundancy and backups are not cheap. It comes at the expense of efficiency, but we might think about it as investing in some of those things as a form of insurance against future risks.
Thank you. Well, we have time for one or two more questions. Would anyone else like to ask a question? Do we have the microphone, please? It's being recorded, so it's probably good to have the microphone. Oh, sorry. Here he comes.
Whichever continent you are representing, of course, the future of food and agriculture is very important. Thank you, Professor Lusk. It's a very interesting talk, See, one of the questions, in fact, I have so many questions that I thought of, in fact, to restrict to only two. So one of the questions, in fact, of course, you already had some kind of, inputs to that, see, the food habits, for example, 100 years down the line, the food intake pattern, do you expect that the same way that we have to do today? Or it should be different, some advice? So whether the humans require these long, whether long, small intestine is it required or some kind of management in the human body itself is required to meet these kinds of huge demands in future? So that is one of the questions. And second one is that, see, we always believe that, organic farming and organic foods are good and we should in fact move towards that. But one of these slides you have shown that in Sri Lanka, in fact, this organic farming has in fact caused a lot of trouble to the country, So which is best? What is your advice? Is it that kind of movement is good or bad to your country? Thank you.
We could talk forever about both of those, so I'll try to keep it short. The first one, the way I understood what you asked is, can diets change over time? And I think even over recent history, we can see the answer is yes, they do change. At the same time, they exist along cultures. Most of us enjoy what our moms cooked, at least I did. Those are the things I still like today. So there's a part of us that's always connected to our past. At the same time, we can see trends in food movements where people are consuming new things. Michael Pollan is a popular food writer. I have some arguments with him, but he has a title of a book called The Omnivore's Dilemma, which the dilemma is we have to be, as humans, conservative enough that we don't eat a wild mushroom that's going to kill us, but at the same time risk-seeking enough that we try new things and that we can live and thrive. And I think that's the way humans sort of navigate our food world. You ask about the organic agriculture. I think economists have a saying, there are no solutions, there are only trade-offs. And organic has a lot of benefits, but it's not free. And organic tends to have lower yields. It's not always better for, say, greenhouse gas emissions. In some cases, you can have more greenhouse gas emissions per bushel produced because you're producing fewer bushels. And so I think that's the challenge is, I think many of us, including myself, would like to move to a world where we're using fewer synthetic chemicals. We could rely on less synthetic fertilizer. I'd like to move in that direction too. But just saying we can't use those things without any good idea of what the alternatives and consequences are, I think is where the problem comes in. So let's think about the innovations that can let us use less fertilizer, that can help us move away towards some of those things. I think that's the way I think about it. Not that I don't want that same outcome, I do. It's just I want it without the massive disruptions that are going to be required to get there. Maybe one statement on that, I think is an incredible estimate I've read somewhere that I'm going to get the exact number wrong, but it's something like 65% of the world's population would not be alive today if it wasn't for the invention of synthetic fertilizers. That cat's out of the bag. So, we can get rid of those synthetic fertilizers, but you can't support today's world population without it. And so, without a solution to that problem, we got to manage that conversion over a period of time while we innovate.
Yeah, and I would like to say that we could introduce a semi-organic kind of a concept by employing the new digital technologies. So, say for example, by tracking the parts of the field where putting more fertilizer is going to produce more, maybe a better solution rather than applying uniform amount of fertilizer all over the field and getting worried about that. Similarly, applying chemicals only in the particular part of the field where the plants are sick may be a better solution. It will help our environment, it will help our water bodies, and it will also help the bottom line of the farmer because they are not investing a lot on the input, which is not going to be used by the plant all over the field. So it is not 100% organic, but it may satisfy those who are against applying a lot of chemicals and synthetic fertilizers to produce more.
Thank you.
Just quickly to add to the point on your question on the diet, most of the wealthier countries, people are moving towards plant-based proteins, like almost the animal-based proteins. The dependence or the need for animal-based proteins, almost it's flattened out. But developing countries, they are now depending more on animal proteins. For example, India, I read from a report that animal protein or meat-based protein, the demand is increasing at about 3 or 4% every year. So it's kind of changing, but how it's changing, how do we, how it changes the diet, it's still, it's a mix, kind of, you cannot decide based on one kind of situation. So there are like different things that, coming around or,
Great, thank you. Thank you so much. Actually, we are at the end of our time, but the good news is that lunch is waiting for you, and we will all be around. So I would like to, first of all, thank our speaker, Professor Lusk, our panelists, Professor Ambrose, Professor Saraswat, and thanks to all of you for coming. And we invite you to lunch, and we can continue the conversation over a meal, which is apt because, you know, we're talking about food, and,
yeah.
and that we can continue the conversation over food. So thanks again for coming.
Thank you.
Let's get a photo.